Okay, so climate, kind of finish up our weather unit. Has a lot of topics that we discussed before. Average weather conditions in a certain place over a long time frame. So when we talk about weather, we're talking about what's currently going on. But when we talk about climate, climate is the average area in an area over around a 30-year time frame. They take a look at what's going on over about 30 years, and that gives them an average picture of the area. All right, we got some big issues. We use the term mellows, a little acronym, mellows. And mellows gives us our 7 big issues that help us determine the climate of an area. So M, mountains. E, elevation. L, latitude. L, large bodies of water. O, ocean currents. W, wind belts. And S, storm tracks. All right, mellows. All right, let's take a look at each of them kind of individually. Mountains. When you have a mountain range, wind blowing across the ground, it has to go up when it runs into a mountain. There's nowhere else it can go. And then that brings into play that recca, R-E-C-C. So rising air expands, it cools, and then the water vapor that's in there condenses. We call that the orographic or the rain shadow effect. On the windward side of the mountain, you're going to get a lot of moisture, a lot of precipitation, greener areas. But on the opposite side, called the leeward, it's going to tend to be drier and warmer. You get a lot more desert-like conditions on the leeward side. All right, elevation, pretty simple. The higher you go, the cooler the temperature. We're talking, about the troposphere right now. We're not talking about the other layers. So we're talking about the troposphere. As you go up, as you climb up a mountain, you got to put your coat on. It gets colder. Latitude. Generally speaking, as you move away from the equator, you're going to get cooler temperatures and you're going to get a bigger range. All right? If you live near the equator, what we call the tropics, the tropical areas, it's going to be pretty fairly warm year-round. You're not going to get a whole lot of variation. But where we are in the temperate zone, you can see the green area on this map, in the temperate zone, you get bigger ranges of temperatures from summer to winter. Okay? Large bodies of water, what we call a marine or a continental climate, depending on where you live. Marine climate, if you live near a large body of water, ocean, large lakes such as the Great Lakes. Continental means an inland area. All right? So this has to do with the specific heat of water. All right? Water has the ability to absorb and hold a lot of energy. So in the wintertime, if you live near water, all the heat energy that's in that water is going to be released to the atmosphere around you, and it's going to keep your winters from getting too cold. And then in the summertime, those bodies of water are going to absorb a lot of energy, and it's going to keep your summers from getting too hot. Right? They act as energy reservoirs. They're very good at holding energy and slowly releasing it. All right? So that we end up having what's called a continental climate on an inland area, where we get really, really warm summers and really, really cold winters. And if you live in coastal areas, generally speaking, you're going to have milder summers and winters. They're not going to get too hot, not going to get too cold. All right, ocean currents. Generally speaking, if we look at this map from our reference table, okay, if you look in the northern hemisphere, we generally get clockwise circulation in the ocean basins. And because of that, if you're on the west coast of a continent, the water is going to be flowing toward the equator, which means it will have come from a higher latitude, so it's already colder to start with. Where if you're on the east coast, the water is going to be flowing away from the equator, so it's going to have been warmed already. And so you're going to have a warm current. And it's just the opposite in the southern hemisphere. This little diagram here kind of shows what's going on. You can see 50 million years ago right here, Antarctica was actually warmer because the southern tip of South America and Antarctica were connected. And so these currents were able to stay trapped. But once it's separated, that allowed the water to flow through. And so we have this west wind drift, or what's called an Antarctic circumpolar current, that's able to just continually flow around Antarctica like this, unobstructed. And that kind of traps any warm water from coming in. And so Antarctica froze over, and we have what we have today. All right, wind patterns. No, I guess we're doing storm tracks first. Oh, well, that's okay. All right, so storm tracks. Patterns determine the weather movement. So I told you before that I like to look at Syracuse weather because Syracuse is west of me and we are in the prevailing westerly wind belt. So weather tends to move from west to east across the United States. So whatever is west of us is going to be hitting us over the next several days, whatever we're talking about, whatever kind of time frame we're talking about. So it's a little kind of a good way to kind of gauge what is coming your way, whether it's high pressure, low pressure, whatever it may be. All right, now back to wind patterns. All right, so if you're at the equator, or you're at 60 north and 60 south, we're going to get low pressure. And anywhere you have low pressure, the air is lighter, it rises, we get clouds, we get precipitation. We can see that on this little guy right here, this little map here. Okay. So at the equator, you look over here, the arrows are moving off the surface, away from the surface, so the air is rising. And at 60, right here, you can see these arrows also are moving up off the surface. Okay. Because of that, those areas tend to be wetter. Those are low pressure areas where it tends to be wetter. Whereas 30 north, 30 south, you can see the arrows are pointing toward the surface, they're going this way. Same here. And at the poles, the air is sinking toward the surface at the poles. That means those areas are drier areas. Those are high pressure areas. All right, so 30 north and south, and at the poles, we're going to get high pressure, clear skies, very little precipitation. I think that's where a lot of our desert areas are. These different pressure bands give us the different general climate areas. The equator, where it's wet and hot all the time, that's our tropical rainforest. All right, 30 north, we're talking, from the southwest, we're talking about Texas, across Arizona, New Mexico, California, you got the Mojave Desert, you got Phoenix, all these areas right here, that's where your desert areas are, that particular latitude. You go to 60 north, these are your snow belts. It's up in Canada. We're going to get precipitation there, but it's going to be cold, so you're going to get more snow than you are rain. And then when you get to the pole, there's very little snow at the pole, so it's technically classified as a desert. They don't get much precipitation there at all. All right, that gives us three basic climate zones on the planet. All right, we have what's called a tropical climate zone, and those are rainforests, deserts, savannas. You don't really need to know the different subcategories. Just make sure you understand that right around the equator is what's called a tropical zone. Okay? Here where we live, it's called a temperate zone or mid-latitude. All right, we live in the mid-latitudes. 43 degrees north is about halfway between the equator and the North Pole. And then when we get to the poles, you have your polar, climate zones. All right, and we can represent the climate of any particular area on what's called a climograph. Climatograph plots temperature and precipitation on the same graph. They use a line graph for temperature, and they use a bar graph or a histogram for precipitation. They put it together, and by combining those two, you can differentiate different climates around the planet. All right, so here's a couple examples. We got Algeria is a good prime example of a desert. You got cooler winters, warmer summers, but you can look at the blue precipitation lines in Algeria, and you can see that there's very little precipitation. But if you look at Peru, okay, look at the temperature line in Peru, it's pretty constant year-round. And then when you look at the precipitation, it gets a lot of it. Okay? Peru's at the equator. It's a tropical rainforest. These are two prime examples of a desert, and tropical rainforest. Okay? Good range in temperature, very little precipitation for the desert. Not a big range in temperature, a lot of precipitation year-round for the tropical rainforest. Okay, if you notice that one, see that desert right there? It looks very similar to the one for Algeria. It's a good prime example. Okay, take a look at the one for Peru. And now let's look at this one. Almost identical. It's tropical rainforest. And then finally, the temperate. This is kind of us. All right, we do get a pretty big range in temperature over the course of the year. And we get a moderate amount of precipitation. Right? We're kind of in the middle. The only thing that would change in the southern hemisphere on this would the temperature line would be, instead of a kind of an A shape, like this, it would kind of be a V shape like this, because your higher temperatures in the summer would be in January and December for the southern hemisphere instead of winter for us. All right, finally here, a little bit about climate ratios. Climate ratio can give you an idea of the general conditions of an area. We look at a couple different things. We look at precipitation, and we look at the potential for that area to evaporate its precipitation. So it's the P divided by EP ratio, P over EP ratio we call it. So for example, if you have a place that gets very little precipitation, but it's really hot year-round, like Phoenix, if it does rain in Phoenix, it evaporates away quickly, almost instantaneously. So they have very little groundwater. It's very dry there. Right? So they have a very, very low PEP ratio. Okay? A small number on top, a bigger number on the bottom makes a very small fraction. Right? The smaller the fraction, the drier the area in general. And so you got your four main types depending on what your ratio ends up being: arid, semi-arid, subhumid, and finally, if you have an area with a lot of precipitation but it can't evaporate very much, maybe it's colder a lot of the time, it's going to be humid.